Event-driven architecture is one of the most widely adopted patterns in Node.js, and it's deeply embedded in the platform. The fundamental idea is that your code should be reactive to events instead of constantly polling for changes. An event is a state change, a network connection being established, data arriving, a file handle being closed. Objects that need to be notified of such changes, consumers register as listeners on the object producing the events, the producer. When the producer detects a state change related to it, it notifies all listeners. This pattern is very effective when you need to communicate inside your application in a one-to-many relationship, because it gives you very loose coupling. This is especially valuable in a service-oriented architecture, where application components, your services, remain loosely coupled and can be upgraded over time without affecting other services. Imagine you have a sessions service responsible for creating and destroying user sessions. When sessions change, the service emits events. Other services just listen for the events they care about. A service that only wants to know when sessions are created listens only for the create event. New services can be added without touching the existing application code. The publish-subscribe pattern is a network-based variation of the event-driven pattern. Instead of events, you have messages. Instead of listeners, you have subscribers. Instead of event emitters, you have publishers. The main advantage, it works over the network layer, so services can communicate across the internet. The trade-off, it introduces a third element responsible for accepting publisher messages and delivering them to subscribers, adding potential complexity, slowdowns, and points of failure at the network layer. 2 pitfalls to watch an event-driven code. First, never create a deadlock by waiting for an event that never fires. Your application won't crash, but it will be stuck in an intermediate state and leaking memory. Second, always handle errors gracefully. Core modules like HTTP and net throw exceptions when you don't handle error events, triggering uncaught exception and stopping your application. Streams and events are deeply related in Node.js, and not by accident. Streams use events to inform consumers about data availability and end of data. Every stream is an extension of an event emitter. In its most basic form, a stream is a process of emitting data events with content from some kind of buffer. You can think of streams as Unix pipes. The goal is to be as useful as piping data across commands: read it, process it, transform it, output it. Streams are a fast and easy interface for creating 4 types of data flows. Readable streams are your data sources. A file parser reading CSV and emitting data events for each line is a readable stream. A readable stream can be in flowing mode, data is piped as it becomes available at the source, or in paused mode, where data is fetched manually when needed. Writable streams are your data destinations. Writing to a file, responding to a client, compressing data with slib, encrypting with the crypto module, these are all writable streams. A writable stream writes data to its destination and reports back pressure when data is being written faster than it can be processed, forcing the stream to buffer data in memory. Duplex streams handle both source and destination simultaneously. Sockets are the most common example. You can both read from and write to a socket. Compression streams and cipher streams can also be duplex depending on the objective. Transform streams are a special case of duplex streams where you perform a transformation between source and destination. Compressing data is the most common example. You read uncompressed data in and write compressed data out. Converting between formats like JSON to binary falls in this category as well. The beauty of streams in Node.js is piping. You can connect streams together with pipe, passing the output of a readable directly into a writable, or through a transform. This avoids loading entire files into memory, and the platform handles all the coordination. JavaScript was designed as a language for the web, and it handles text using Unicode. That's great for strings, but binary data is a different beast entirely. When you're reading raw network packets, processing image files, or parsing binary protocols, you cannot safely represent that data as a JavaScript string. Characters might get mangled, bytes might be misinterpreted, and data integrity is at risk. This is why Node.js introduced the buffer class. Buffers are an alternative to manipulating data with strings. They give you access to raw binary data as a sequence of bytes. And they come with a full set of methods to read and write numbers in different sizes: 8-bit, 16-bit, 32-bit, whether signed or unsigned, whether big endian or little endian. Because of binary compatibility requirements, the core Node.js modules use buffers in stream data events. When you stream a file to a client or receive a file from a client and write it to disk, the data flowing through the streams is passed as buffers. You don't have to think about encoding and decoding, the platform handles it through buffers. This is one of the reasons piping streams is so simple. Streams pass buffers to each other, and the binary data stays intact through the entire pipeline. The buffer class is also important for performance. When you work with large binary datasets, think video streams, file uploads, database binary columns, using buffers avoids the overhead of string encoding and decoding at every step. Understanding when to use strings and when to use buffers is one of those distinctions that separates developers who write performant Node.js code from those who don't. The rule of thumb: if it's text meant for human consumption, use strings. If it's binary data, network packets, file bytes, protocol payloads, use buffers.